So now that Mary Claire can see what we're doing once I put this online, we're a little behind, but we did that first step. So this has a microphone in it. It audio records, but it just barely picks up what I say. So if you say something, it's probably not gonna catch you unless you're really loud. I need a better microphone. So we have all of this. Let's clean up what we've got, at least on that top part right there. So f prime of x equals, the first part's just x squared plus 4 to the 1/3. And then we've got minus, I've got x, I've got 1/3, and I've got a 2x. So that's going to give me 2/3 x squared times x squared plus 4 to the negative 2/3 all over x squared plus 4 to the 2/3. And right here, we're at that 1/3 power raised to the second power. We just multiply those exponents, and that will give us the 2/3 power here. If it's free response, stop here. Just clean it up a little bit and leave it. But it's probably not going to be, so we need to know how to simplify this. So just like we saw with the product rule problems, we've got these pieces right here that match. So we want to factor that out. So we want to factor out the x squared plus 4 to the lowest exponent that we have, which for this one would be 2/3, or the negative 2/3. So we're going to have f prime of x equals, we'll have x squared plus 4 to the negative 2/3 times, and what we're doing when we factor that out is we're dividing by x squared plus 4 to the negative 2/3. So when I divide this by x squared plus 4 to the negative 2/3, it's going to be 1, because 1/3 minus negative 2/3 is going to give us 1. You'll see that happens most of the time, which makes it simplify a little prettier. So this is going to be x squared plus 4. And then over here, when I divide by x squared plus 4 to negative 2/3, that's the same on top and bottom, so they just cancel out. So I get minus 2/3 x squared all over x squared plus 4 to the 2/3 power. Is everybody with me there? So now you should be seeing a few things that still look like you could do some work with them, because this x squared plus 4 matches this x squared plus 4 in the bottom. Yes? Where it's multiplied right here. Right here, when we factor out the x squared plus 4 to the negative 2/3, since we're taking that out front, then it is gone. This cancels out to be 1. If we wanted to multiply it back, we would multiply it back, and we would see that we would multiply it by the x squared plus 4 to get that 1/3. Then we'd multiply it back here, so it would be multiplied. So we're pulling it out front as a factor. So it's still multiplied. We would just have to distribute to get it to multiply back there. So what I'm going to do is I'm going to send this back down to the bottom. It's got a negative exponent. And then I'm going to combine some stuff up here in the top. So in the numerator right here in this, I've got an x squared and I've got a negative 2/3 x squared. So that's going to give me 1/3 x squared plus 4 over, and then I'm going to have x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3. Right, I'm just taking this x squared plus 4 and moving it down to the bottom since it has a negative exponent. And so we're getting very close to what would probably be your answer. what could we do with those two bottom? Okay, we can combine them, and what will we get when we do? Nope. If we were adding them, it would be 2x squared plus 4 to the 2/3. But these are multiplied together. So if I have something like x to the third times x squared, that'd be x to the 5th. I add those exponents. So we're going to do 2/3 plus 2/3 to get 4/3. So we're going to have 1/3 x squared plus 4 over x squared plus 4 to the 4/3. So we're really close right now. In fact, a lot of times I think it could possibly be left like this, but a lot of times they don't like to leave fractions in fractions. So since we got that 1/3 on top, what could we do to get rid of the 1/3? We'll multiply by 3. So if we multiply the numerator by 3 and the denominator by 3, then that's a legal move because it's still an equivalent fraction. So finally, we would get x squared plus 12 over 3 times x squared plus 4 to the 4/3. And this is how I think you would probably see the answer choice on a multiple choice question. Or some version of this. It might be cube root of x squared plus 4 to the 4th power. It could possibly leave some negative exponents or something, but you're probably going to see it simplified down in this manner of some sort. So, questions? Let's see. I think I'll show you. Yeah. All right. I'm on this next problem here. I'm gonna solve it a different way. You may like this other way better, and if you do, please use it. I always use this method whenever I did basically any problem whenever I was in high school. So for this problem, we could do just like we did on the last problem. Numbers are different, but the same process on the last problem. Or I'm going to show you what I used to do whenever I was in high school on these. I would make this 2x times x squared minus 4 to the negative 1/2 power. It actually might be a little easier on this, maybe. We'll see. And that way, I don't have to do a quotient rule. I just do a product rule. Right? I've just moved this x squared minus 4 up to the top, and rather than having a 1/2 exponent like it does in the denominator, I made it a negative 1/2, so I could move it up to the top. So then, whenever I take the derivative, I just have to do product rule and not the quotient rule. So product rule, this 2x is my f. This x squared minus 4 to the negative 1/2 is my g. So I've got 2x times g prime. So here I have to use a chain rule. So I have negative 1/2 times x squared minus 4 to the, what do I get for my exponent here? Negative 3/2. Make sure you subtract there. Times the derivative of x squared minus 4, which is 2x. Plus x squared minus 4 to the negative 1/2 times the derivative of 2x, which is 2. So this is my f. All of this right here that I used the chain rule on, that was my g prime. This is my g. This is my f prime. So we want to clean this up a little bit. So we've got 2x and a negative 1/2 and another 2x. So 2 times negative 1/2 times 2 is going to give us a negative 2. And we've got an x here and an x here, so that gives us x squared. And then we've got our x squared minus 4 to the negative 3/2. And then on that second term, let's just move the 2 to the front. So we've got 2 times x squared minus 4 to the negative 1/2. So this will treat like those product rules that we were doing last night. These two right here match. It's just a little more difficult because we've got fractions that are bigger, a little bit bigger fractions this time. So what would we want to factor out here? X squared minus 4 to what power? Negative 3/2. Okay. So when we factor that out, we're dividing both of these by x squared minus 4 to the negative 3/2. X squared minus 4 to the negative 3/2. All right. So right here, they cancel because they're the same top and bottom. So we have negative 2x squared. For the second one, when I am dividing, I subtract my exponents. So I have negative 1/2 minus negative 3/2, which really means that it becomes addition, right? So you get 2 over 2, which is 1, right? And I've told you it's usually going to be a whole number. So we keep that 2 that is right here, but then we have x squared minus 4 to the first power. We don't need to write that 1 there. So f prime of x equals x squared minus 4 to the, actually let's go ahead. I'm going to go ahead and move that to the bottom. You guys alright with that, since it has a negative exponent, so I have x squared minus 4 to the positive 3/2. We move it to the bottom. And then if we distribute our 2, we've got negative 2x squared plus 2x squared minus 8. And then these cancel. So we end up with negative 8 over x squared minus 4 to the 3/2. I don't know, I think I still might like doing it with the product rule a little bit better. This one was a little easier problem than the last one too, because we had some things that canceled. Maybe. Our textbook is very inconsistent on what they leave their answer choices as. On some problems, they leave it like this. On some problems, they change it back to a root. If you changed it back to a root, it would be the square root of x squared minus 4 to the third power. Yeah. So it just depends on what you see there. All right, questions? Let's see. Let me see what I've got here. I guess we'll do both of these. Actually, I'm going to let you guys try this one on your own. Okay? Try this one on your own. I'm going to pause. this part right here is your f. And this is your g. So this is my g prime. So when I take the derivative of that, I have to do the negative 1/2 x squared minus 3 to the negative 3/2, but that one has to have a chain rule. So you got to take the derivative of the x squared minus 3 that's on the inside. So that's where the 2x comes from. There. Yeah.
I just didn't distribute negative.
Yeah. Yep, be careful with those. Okay. It's easy. There's a lot of steps here. It's easy to miss one little thing that'll throw your answer off. Which makes it even worse when you have multiple choice, because I don't account for that on multiple choice. So, any other questions? All right, let's do one more that's a little different. We'll do this one together. We'll give you the same. Okay, yeah. Now, this one is different. How is this one different? It's all squared. So your chain rule comes first on this one. On the others, your either product or quotient rule, you had to do that part first. But then you, inside of that, did a chain rule. Here, the chain rule comes first. So you've got, this is your outside, and this stuff right here is your inside. Okay? So what you'll do when you take the derivative of this is you'll say 2 times 3x minus 1 over x squared plus 3 to the first power. You don't have to write that to the first power, but I kind of like to put it there just to remind myself of taking the derivative of that part. But then you have to do the derivative of the inside part, which that is where you have to use the quotient rule. Okay? So we will multiply this by the derivative of the inside, which we're going to use quotient rule for. So that's going to be low d high, which is going to be 3, minus high d low, which is 2x, all over x squared plus 3 squared. Okay, any questions so far? All right, now I would keep this stuff out front separate for a little while. Because you'll notice you've got the same denominator here, so eventually we're going to combine those. But for right now, let's leave it alone and let's just clean up what we've got in this numerator right here. So we are going to say 2 times 3x minus 1 over x squared plus 3 times, and then if we distribute this 3 here, we get 3x squared plus 9. Here, we're distributing this 2x, so we've got minus 6x squared. We're also distributing that negative right there, so if we're trying to do that all at once, it's like we're multiplying by negative 2x, so we're going to get plus 2x here over x squared plus 3 squared. And then so let's combine what we've got here. So we've got negative 3x squared plus 2x plus 9 over x squared plus 3 squared. So you could see the several different ways they could try to put the numerators together there, but I don't think that they will. What I think you'll probably see is that the answer choice will look like this. 2 times 3x minus 1 times negative 3x squared plus 2x plus 9. I think they would just leave all of those in factored form there. And then the denominator, we've got x squared plus 3, and then we've got an x squared plus 3 squared, so we can combine those and get x squared plus 3 to the first power. First, losing my mind. To the third power. There, add those, not subtract. And I think you'd probably see it left like this, although they could multiply these numerators together or something, so you would want to look at your answer choices to see what you have there. Okay, questions? All right, I'm going to add in one more that here, let's just go back right here that I left off of these notes. So example 5, and this one's a pretty quick one. This one is not a quotient rule. This is just one that trips students up sometimes. Sine cubed of 4x. Okay, this one throws students off a lot of times. The biggest reason I think it throws students off is the sine cubed of 4x. So what we really need to do is think about what that sine cubed means. It means we've got sine of 4x, and all of that is cubed. That's the way that we write. Typically with trig, we put that cube, instead of putting it on the outside here, we put that cube right here next to the sign. But this is what it means. So this actually is a triple chain rule right here. So you've got that 4x is your most inside part. Then the sine of 4x is the next box, and that to the third power is the outside. It's a little harder to see when it's written like this because it looks like it's right there in the middle of it. So if we take the derivative of this, we'll have 3, leave this stuff the same, sine of 4x squared. Right, so all we've dealt with there is the exponent to the third power there. Then we have to take the derivative of the green box, the sine of 4x. So what is the derivative of sine? Cosine. And we leave the 4x alone. And finally, we have to take the derivative of the red box, the most inside. The derivative of 4x is 4. So the derivative of this, there's not much you can do to clean it up, but we would probably write it like this. We'd combine that 3 and 4 to get 12. And then typically we'll see this written sine squared 4x times cosine of 4x. We'll write that square back on the inside of that sine function. These, a lot of times, students leave off a step of that because it's the fact that it's a triple chain rule is not quite as obvious to them. All right, any questions? All right, you do not have a lot of questions for homework because they are these more difficult questions. So homework tonight will be page 168, 27 through 34. And I'm going to go ahead and give you the multiple choice part of the test review in case you want to look at it. It's not due yet, so I'm just going to go ahead and give it.